Okay, welcome to systems of equations. Now we have two methods for systems of equations. We have substitution or elimination algebraically, and then we have the third method of graphing. But I'm going to focus on substitution and elimination. So for substitution, we take our two equations, and they must both say y equals. Well, they say y equals, so we're okay to set up. So I take my first equation, x squared plus 3x minus 5, and I set it equal to my second equation, x plus 3. I'm just removing the y's and setting my two expressions of x squared plus 3x minus 5 and x plus 3 and saying those equal to each other. Now for my second step, I need to get everybody to the same side. Now you should always look at your x squared term. If he's positive, move everybody to his side. If he's negative, move everybody to the other side. So because he is positive, we're going to move our x plus 3 to the other side by doing their opposites of negative x and minus 3. And the right side is now equal to 0. My x squared just comes down because he has nobody to combine with. 3x minus an x gets me plus 2x. Negative 5 minus 3 gets me negative 8. And now we're to factoring. So we are looking for numbers that multiply to negative 8, but when I add those numbers, I get 2. So off down here, negative 8, I'm just looking for numbers that multiply. Well, I know negative 4 times 2 will get me negative 8. But if I add these, negative 4 plus 2, that gets me negative 2. I want a positive 2, so this does not work. So let's try the opposite. 4 times negative 2. 4 plus negative 2 or 4 minus 2 is positive 2. That does work. So now we can write out our factored form. Instead of x squared plus 2x minus 8, we can write its factored form of x plus 4 because he's positive times x minus 2 because he was a negative equal to 0. My next step is to set both of these equal to 0 and solve, but because our x values are just an x, we know there's a shortcut, and I can just set them equal to the opposite values. So the 4 was negative, or was positive, so the x is equal to negative 4. The 2 is negative, so my x is equal to positive 2. Okay, we're about more than halfway done. Our last thing we need to do is we found the x values to our system. Now we need to find the corresponding y values. So I'm going to take these x's and plug them back into one of my two equations. Now, it doesn't really matter who you use, but for simplicity's sake, you should always use the linear. It's a simpler equation to solve. So we have y equals, I'm going to pick my first value of negative 4 that I plugged in for x plus 3. So I just plugged my negative 4 into the x. And now I solve. Negative 4 plus 3, or 3 minus 4, gets me negative 1. So I have the value of negative 4 that I plugged in, and I got the answer, negative 1. There's our first answer. Now we have to do the same with this 2, so y equals 2 plus 3. Again, just replacing the x with 2, and I get 2 plus 3, which is 5. So I get the value of 2, erase that because it doesn't look much like a 2, 2, comma 5. Okay, and now to elimination. This is the same problem, but using the opposite method. So for elimination, again, you must be y equals on both your equations. Again, they both are. So my next step is to stack them on top of each other and subtract the like terms. Well, I have y minus y, which gets me 0. This is why we need it to equal y, so that we get this 0 here. I have x squared, but I have no x squared term in my second problem, so he can just come through. I have 3x minus an x, so I have 3 minus 1x, which gets me plus 2x. I have a negative 5 minus positive 3, so it's like negative 5 minus 3. Well, they're both negative, so it's like adding, so minus 8. And again, now we're back to factoring. So factors of negative 8, well, we saw in the last one, it's positive 4 times negative 2, and when we add them, 4 plus negative 2, we get positive 2. So same factoring, x plus 4, x minus 2. I'm going to switch my 0 to be on the right side. It doesn't matter. Swapping to our answers, x equal to the opposite of positive 4, which is negative 4, the opposite of negative 2, which is positive 2. And again, now I just use these numbers and I plug them back into one of my equations. Again, doesn't matter, but you should always go for your simpler problem of the linear. So y equals negative 4 plus 3, which gets me the y value of negative 1. So again, negative 4, negative 1. And plugging in the 2 plus 3, and y equals 5. So we get the answer of 2, 5. Now, as you can see, I did one with elimination and one with substitution, and it didn't matter. I either got the answer negative 4, negative 1, or 2, 5. Same answers with elimination. It doesn't matter what method you use, you just have to know one of the ways.